Thanks for having me here. It's always nice to be at a formal methods event. This is not the majority of events in artificial intelligence these days, sadly. Okay, so this talk basically is, since I got an hour, is going to be two parts. One of the parts is basically describing and motivating this field that we call machine ethics, and then motivating the part of it that I'm interested in. And the rest is about a very specific work that we are working with some people in Bergen. So disclaimer, I am a computer scientist, and I'm currently in a department called Information Science and Media Studies, which is part of the Faculty of Social Scientists. So some people sometimes confuse me for a social scientist, but not for very long. And I am a person that I do not have a very large group of people that I work with. So the type of work that I tend to do is a little bit of here now, a little bit of here then, and so on. So don't expect grand things with solutions. It is exactly what it seems. Okay, so there was a concern that has been expressed, and I think I don't have the paper later, that machine autonomy is threatening to override human autonomy, and that this is something that is something that we should be concerned about from an ethical standpoint. Because autonomy is one of these values, one of these ethical values. It is the value of having the opportunity to decide for oneself what you want. And it shouldn't be confused with the value of freedom, which is attaining for yourself what you want. So autonomy is really just about the possibility to decide, and then freedom is about the power to pursue what you have decided. And this is a very old paper. I got this very clever idea at one point that it would be super cool to put the links to the papers as QR codes, and we'll see halfway through I changed my mind. So because it's a little bit of a lot of clicking, but that's the paper. So this is a relatively old paper as far as computer science goes. It is from 2000, and it is a paper that tries to bring in levels of machine autonomy compared to in the scope of interaction with people. And here we distinguish between, so there are a lot of these, some of these have been recently defined, to levels of autonomy of cars, levels of autonomy of boats. This is levels of autonomy in interaction. So the lowest level is the computer offers no assistance, human must take all decisions and actions. The next above it, the computer offers a complete set of decisions, action alternatives. The third one is narrows the selection down to a few. More autonomy for the machine suggests one of the alternatives it has narrowed down. More autonomy executes the suggestion if the human approves. More autonomy allows the human a restricted time to veto before automatic execution of the choice. More autonomy executes automatically than necessarily informs the person, human, after the fact. More autonomy informs the human only if asked. And more autonomy informs the human only if the computer decides that it is important to do so. And the most autonomy is the computer decides everything, acts autonomously, ignoring the human. So the field that I'm working in, this ethics, is basically very much concerned about what happens when you automate certain decisions. And a lot of the subfields of AI ethics are around specifically this issue of autonomous decision-making and concerns that when we automate decision-making, we don't really take into consideration everything that needs to be taken into consideration. So it is very easy to, and we saw it in some of the talks yesterday, it's very easy to forget things. We cannot just automate decision-making based on, okay, this is your set of alternatives, this is the properties of all the alternatives with respect to the goal that you're trying to achieve, and then you maximize expected utilities or apply whatever application function there, and you just choose one. The problem with that is that We make exceptions to accommodate or increase the well-being of others. So the example I give is you are at the pedestrian crossing and the light is red, but there are no cars out there. So of course you're just going to cross because that optimizes your goal, which is to get to your destination efficiently. But if there is a parent next to you with a small child and you see that they're trying to teach them what is the safe and not safe way to cross the street or what are the rules, if you cross the street and gain that 10 seconds on your daily out, you undermine this effort of this other person to teach their child something useful. So you're going to stop there and wait the 10 seconds, even though it is perhaps not the most optimal way, selfishly seen. Moral decision making is a complex reasoning problem because so much of it is under-specified. I think maybe it will come up in a slide later, but it is very difficult to define what it means to decide ethically, even though there is the entire field of moral philosophy that has existed for at least 2000 years, I would say, on trying to figure out what is right, what is wrong, how do we differentiate between the two and so on. So some consider that, some being Hare, I think typically if we need a reference, that to decide morally means to take the preferences or the values of others as of equal weight of one's own. Practically, that is not what happens. This is not what we are doing. If I'm going to dare choose which coffee I want, and I'm going to start considering the preferences of others of equal weight of my own, you know, the cows, the coffee pickers, the people that are behind the counter and so on, there will never be coffee. So we do some shortcuts, but what shortcuts we do seems to be always different. Okay, so second half of the talk is based on this paper, which is we put it on archive for purpose of talks, and it's very much work under development. But if you want to see the allegedly simple proofs of things are in there. Okay, so let me focus a bit on machine ethics. So machine ethics as a field happened in way before these topics of explainability and fairness and other ethical AI and responsible AI and all that. And it basically rose out of the concern how the machine behaves towards human users and how does it behave towards other machines. So the link there is basically to a paper of 2006. They had early 2006 or 2005, there was some AAAI spring or autumn symposium. People realized that there are a lot of disconnected works. They all basically center around the same problem and that they wanted to bring it together and give it a name. So the name they gave it was machine ethics. Now, machine ethics, it can be approached this concern with the behavior of machines towards human users and other machines. It can have, you can take a very humanities perspective of it and study problems of what does it mean for a machine to be moral. So here, one question that people ask from philosophy would be, can machines ever be moral agents? What does it mean for, is it the same thing? We know that the machine is not really quite this agent as people are. We have these theories in moral philosophies that are developed around the idea that you have a fully autonomous, fully agenting agent. Can we just stretch them to something that is effectively an object? And then I see a lot more works on the topic of what do people expect from a machine when they talk about ethical behavior of a machine. So certain behaviors are acceptable when they come from a person, but they're not acceptable when they come from a machine, and vice versa. So the example that I have heard here that's very good, if you see a human, this is not a good example, it came from America, so I don't think in German is quite the same level, but if you see a human trample down the American flag, so if you see an American man trample down the American flag, this is an ethical violation, and I think some illegal violation. that it's not so easy to go over. But if you see a Roomba robot trample down the American flag on its way of cleaning the floor and just chews it up and smears dirt all over it, this is a different type of violation. You will see this. Okay, this is a mistake that has happened. Is not a deliberate act of treason. As Taylor, yeah, there you are. Okay. From a computer science side, when we speak about machine ethics, we typically talk about how to automate moral reasoning. So how do I take this algorithm or process, which is how a machine makes decisions? I think you noticed that I use the term machine both for devices and for software. How we have a way to program these machines to act autonomously to a certain degree. Then the question is, how can we enhance that further so that it also is able to do something that is vaguely not immoral in some circumstances? So how do we automate morals? So the first question, of course, that people ask if we are good scientists is, can you do it at all? Is it the case that a machine can ever be what the philosophers call a moral agent? Now, there are enough papers that claim that machine can never be a moral agent, and this is a wild goose chase. I think the Etzionists typically claim such things in their papers. But in a general conversation, when people say, no, you don't want to build artificial moral agents, typically there is this understanding that an artificial moral agent is something that tells us what is right and wrong with people or a society, that informs us, okay, you should do this, you should not do that. The one good definition that well, in my opinion, is good, that I think that we can in fact work with and do something, because it's very easy to say, no, machines will never be moral agents, bye-bye. It doesn't mean that we can't do anything, we just have to find a different name for them, and that's very difficult because this one is already established. But Floridi and Sanders, in their Morality of Artificial Agents, give us the following definition. They say an action is said to be morally qualifiable if and only if it can cause moral good or evil. So if it has some kind of an ethical impact. And an agent is said to be a moral agent if and only if it is capable of morally qualifiable action. So if the agent does something that has an ethical impact, that agent is a moral agent, and it's as simple as that. Doesn't say how moral qualifiable, just that a threshold is crossed, and we can work with that. So same year that this AAAI symposium happened at, James Moore gave a talk, and then they made him write this paper in which he wrote down what he said during the talk. And he asked the question of, if we can indeed build artificial moral agents, what kind of agents or what kind of moral agents are there? So if you want to study machine ethics, this is basically ground zero paper for reading about things. It's very simple, it's very easy, it's very short, it is 6 pages. So Moore distinguishes between 4 types of artificial moral agents. The weakest one, he calls ethical impact artificial moral agents. And I will explain what they are. Implicit ethical artificial moral agents is the second group. Explicit ethical moral agents is the third. And fully ethical agents is the fourth. Now, he gives a definition for all of this, but since this was a very, hand-wavy paper, the definitions are not very something that you can take, and then I will test my agent and see which group it belongs to. So fully ethical agents, let's get rid of that one first. This is basically same level as humans. So of course, whenever you see ethical, you can also see unethical. I mean, capable of discerning right and wrong and acting and identifying and doing all that stuff. So the interesting ones are the first 3. The first one is agents that themselves, the difference between these 3, and we did a very neglected paper with some colleagues from Bergen, neglected both by us and the general audience, distinguishing between the implicit, the explicit, and the ethical. And we found that the difference between these three very much lies into how the agent uses its autonomy with respect to the morally sensitive situation that it is in. So ethical impact agents are agents that themselves do not do anything. They make no decisions that have any ethical qualities to them. So they do not use right and wrong when they operate at all. However, just because they exist, they change the ethical environment. They have an impact ethically on the environment in which they are. And I will give plenty of examples. Implicit and explicit basically are, implicit ethical agent is one that does make decisions that are morally qualifiable. They are based on right and wrong, but that right and wrong comes from outside of the agent. The agent doesn't determine it for himself. An explicit artificial moral agent is one that in which the agent itself has some way of discerning between right and wrong and using that into its. Good.
Continue,
Okay,
and I will just try to make sure that's
for the patients. Okay, so back from the start, the more example of what is a ethical impact agent is a camel jockey robot from Qatar. So it says that well, in Qatar people like camel races, and in order for your camel to perform great in the race, it needs to be guided, but it should not carry extra weight because that makes it slower. So the way that this problem was solved in the past was by having little boys, typically from Sudan, typically in almost slavery conditions, trained to be camel jockeys and ride these camels. Luckily, the development of the jockey robot has improved on the both of the guidance and the weight conditions of the camels, which made it not necessary to use little boys anymore, which removed the demand on this slavery market and thus improved the condition of society. So from a society in which there was slavery to a society in which there wasn't slavery, at least with respect to this aspect. All grim here. Now, if you're asking yourself, well, then hasn't this been something that some of the technology has been doing for a long time? The answer to that is yes, because this is not the first example. The first example would be the Jacquard machine. So the Jacquard looms were looms that created this beautiful, intricate textile, but the way you accomplish that until the 1700s was that you will have a bunch of little kids on the loom and then a weave master that will scream, you know, now up, now down, now left, now right, or whatever this thing was, until the program for the Jacquard loom was developed. And we're talking about the invention of the punctured card, which made it possible to coordinate the weave on the Jacquard loom and dispensed with the use of these little children that sat on top of the loom. And if you look through history, there will be devices that improved the ethical state of humanity. And of course, you will also find devices that made it worse. This idea of technology being able to change the balance of good and bad in society is basically one of the driving forces behind what we call ethical AI. So ethical AI or AI ethics is a field that emerged, I would say, after 2017. And it has several strands of research and applications, and all of them are basically concerned with how do we make sure that we have control over the ethical impact of this new technology that we are developing. The particular concern stems this time around from the developments in deep learning. However, I've read this very beautiful book that was published in 1956, which is called Automation, Friend or Foe. It's a tiny little book in which we are discussing whether or not automation has a positive or negative ethical impact on society in 1956. It's a very good read. You discover interesting things in it, such as that the first autopilot was developed in 1912 by the Sperry Corporation for crossing the Atlantic. And then there is the exciting last chapters about this new thing called computers. So it's a short read, it's very nice. In AI ethics, but there is no good definition of this is what AI ethics is. This is just one woman's opinion of what I see there. So people typically talk about, and they're how to establish the right relationship between a society forum and AI developer actors. So accountability is a relationship in which the actor describes the behavior of an algorithm. So this is not only about AI. Nobody knows where AI stops and computer science begins and vice versa. So accountability is a relationship always, and it is a relationship in which one actor who is somehow responsible for this algorithm explains its behavior to a forum of interested parties or designated parties, justifies the behavior of all the algorithm, and the forum has the possibility to ask question the behavior and impose perhaps sanctions on the actor if the behavior is not satisfying the properties that the forum thinks should be satisfied. So accountability is actually about that. Transparency is to ensure that the right type of information about the workings of the AI agent is provided to a given stakeholders. So whatever the stakeholder needs, they have access to. Explainability and interpretability are interchangeable in the writings of people, but this, I would say, is the XI field. It's easier if we use the acronym because then we can kind of pretend we don't know what is inside. So this is two parts. A lot of people agree with me on this. Explainability is the first part in which you are concerned with extracting this information that gives you transparency. You're extracting it from your algorithm, and you make sure that it is made available. The interpretability part is considering what needs this person has to understand the behavior of the algorithm. So in this form, if you like, from the accountability part, you understand what needs they have, and then you repack this information that you have extracted through explainability in a form that is useful, that helps the understandability of the end user. So this involves human-computer interaction, it involves natural language processing, it involves question answering, it involves things like this. Explainability, typically people are simply concerned with the extraction of the information in the first place, and they do not care so much as to how do you repackage that to interpret the behavior to the end user. And then we have also fairness and privacy, which is unlike all of these before, which are all actors in the accountability relationship. They're all part of the accountability relationship. Fairness and privacy are, and here trust comes as well, are values of some kind. They're a little bit Frankenstein ethical values, if you like, that we would like that our automated decision algorithms or algorithms of any kind satisfy. So fairness is concerned with ensuring that individuals and groups are treated alike by decision-making algorithms in a representative and in representative data. So what does that mean? I mean, again, you don't have to really look into artificial intelligence or even computer science. In the most abstract sense, fairness is about this machine working the same for different types of people. And it is the classical example here is the Kodak film. When originally developed, it was calibrated in such a way that gave great results if you were of whiter complexions, and it gave very poor results if you were of darker complexion, because they judged that's who their customers is, and they had to choose. And when said customers figured this one out, they adapted this and changed it. Now the Kodak film is pure chemistry. It has nothing to do with computation or decision making or anything like that. But it was an example of an invention, if you like, of a technology that does not work the same. In AI today, when we speak about fairness, we speak about two different things. One is the representational fairness, one is the allocational fairness. In allocational fairness, we're talking about counting whether the desirable decision, the likelihood of getting the desirable decision is more or less proportional between groups of people or individuals. In representative fairness, we're concerned about not feeding machines with data that contains biases in it, and that entrenches a certain position of society and cements it into the systems that we use. So I can go on too much on this, but the moral of the story is today in when we talk about AI fairness, this is a very statistical discipline in which we have statistical measures to count whether a particular supervised learning algorithm achieves certain likelihoods of parity in decisions, which sometimes aligns with the actual ethical value of justice by accident, but it's not necessarily the case that it's a one-to-one match. Privacy is a bit more elusive because there we have two strands. One is the concern that a person is not, the specific data of a person, the specific information that pertains to a person is not identifiable. And the second one, the very, very neglected one, is about the issues that might arise when a person is mapped to a particular data pattern. So identifying a person in specific data, that means I can tell what your home address is from this very large data set, or where you are at the moment, and these things like this. Belonging to a data pattern means, well, men like you who search the internet for these search terms and have bought these items typically tend to have suicidal tendencies. So this is belonging to a data pattern. So both are concerning the specific data identifiability is what GDPR is all about, and the digital privacy, k-anonymity, all the data science things that we see that are called ethical data science, and belonging to data patterns is something that only comes up now. But privacy as a definition, so there are many different definitions of privacy that have evolved throughout the years. It could be the right to be left alone is one of them, and space in which a person can be or act without unsolicited scrutiny. So privacy is a value to a certain extent that attaches very much to autonomy. But I wanted to give that definition not because it's important for what I'm talking about today, but because people don't. And that's wrong. It's morally incorrect. Okay, so then of course we have here a lot of other things. We have trust, we have sustainability, this working for good versus evil, and all that stuff. Okay, the interesting part for us that want to build autonomous systems is we are basically left with two choices when we want to have an artificial moral agent, so which would be some kind of a machine that is able to make moral decisions. So you can have an implicit or an explicit agent. I will just give the pictures which pretty much define what it is. This idea that there are two different ways that you can practically construct artificial moral agents has been mirrored also in the work, not only from, it's not only from the work of Moore, but it has also been mirrored in the work of Wallach and Allen. There are, if you don't want to go to the book, they have written papers that then went into the book. They are distinguishing not between implicit and explicit, they're distinguishing between operational morality and functional morality. These two concepts are more or less the same. So implicit ethical agents are agents that themselves do not have the means to distinguish between right and wrong, good or bad, qualify the decisions in this context. But because they do make decisions that effectively are good or bad, are morally qualifiable, their action is constrained by some kind of a person. So they are ethical in effect, they exhibit ethical behavior, but that ethical behavior does not come because they themselves can discern between right and wrong, but because some person has effectively constrained their available actions so that only using some kind of moral qualification. So this corresponds to, this corresponds to what Wallach and Allen call operational morality. They define operational morality that as a state in which the moral significance of the actions of the artificial agent lies entirely in the humans involved in their design and use. So very simply is that the agent may have autonomy, but it does not use it when it comes to making morally qualifiable decisions. So you can think of this as, if we think of it as not something that happens to artificial agents, but to humans, this would be the state in which a person is put in prison for, and then their behavior is ultimately, well, they don't kill anymore or they don't steal anymore because they can't. We have constrained their autonomy in such a way that they cannot choose this option. So in effect, they're implicitly ethical agents. Now I'm going to step away that unethical things happen in prison anyway, but that's the idea. Explicit ethical agents represent ethics explicitly in some way, and then operate effectively on the basis of this knowledge. So they themselves have some kind of a way to discern between good and bad actions, to discern among actions or states of the world with respect to their ethical qualities. This corresponds to functional morality, which Wallach and Allen define as the ability of an artificial moral agent to make moral judgments when deciding a course of action without direct instructions from humans. So when you're deciding what you're going to choose to construct, it very much depends on what kind of a situation you have. Implicit ethical agents means often you're using a particular moral theory that to govern the effective behavior of this artificial agent that you're constructing. You can either program this or develop an algorithm that follows the ethical theory, or you can use the ethical theory yourself to be able to constrain the actions of this agent. And this, the good property of this is well, we claim verifiable. Then there is no surprises because you're following a pre-decided moral theory. You know what the intended result of the actions of this agent are. Now, of course, you can only do that if you have some oversight of what the context and the possible things that can happen to this agent are. If you have a completely open environment or an environment in which you cannot predict what behavior, what actions will be available to your agent, then it is not an option to build an implicit ethical agent, and then you have to build an explicit ethical agent of some kind. And so this means you are either going to have this agent to learn to follow particular moral theory or moral rules, or examples from an environment, or examples from a specific person. Now, since explicit ethical agency by design means that your agent has autonomy when it comes to discerning between, some autonomy when it comes to discerning between morally qualifiable actions, you may not necessarily know what they're going to end up with calling ethical. And here's the more interesting part, they might even be right? So they might choose different than what a human would choose, but not choose wrong at the same time, which makes it somewhat questionable as to how you're going to verify that the end ethical behavior is indeed ethical behavior. So we don't know, there is no set of benchmarks or established process for certifying for ethical behavior or anything like that. I have to say right away, some people have proposed that we should devise the ethical Turing test to test for this, because you know the Turing test works so well. And so here the idea is that you have a bunch of benchmark decisions, and you have your autonomous system or agent, artificial moral agents choose, and you have a moral expert choose, whatever that is. And if they are, you cannot discern whether it was the machine that has made the choices or the moral expert that has made the choices, then therefore you have achieved moral behavior. And then there's of course the matching paper which says why this is important bad. So if you want those, then just ping me. Okay. So, but whether you're doing implicit or explicit agents, what you're basically doing is the following. You have this box, which is your algorithm. You have some information that already comes into that algorithm about the context, about options, about abilities, about preferences, desires of the designer, and all that stuff. And we already know how to build that-ish. Then the question is, if I add additional information here about moral values or moral obligations or moral sensitivities, some kind of a moral information, how do I then build this algorithm that gives me moral choices? Now, this does not have to be an if-then or a very classical algorithm, rule-based algorithm that you think about. It can be a situation in which you have machine learning producing some kind of a prediction model, and then you use that prediction model to make decisions about individuals. Now, what people are typically concerned in AI ethics is predictive analytics. This is where all the issues come in. Predictive analytics is when you use past data to build a prediction model of future behavior, and then you apply that to judge people. So examples here are deceptive behavior, for example, that is to be implemented on the outer borders of the Schengen zone, detecting whether a person is behaving in a way that they are very likely to have to deceive the border officers. A predictive behavior with respect to, is this student going to struggle with this particular course? Are you likely to default on your bank loan? Are you likely to cheat social services on your welfare application? So this narrows down the group of people who are most likely to commit offense, and then this group of people are much closer watched than others to make sure that they don't. I mean, there's a noble intention behind this, that you save the resources that you have and use them most optimally. But the bottom line is you use a prediction model of future behavior into deciding things today for people. And this is where where you often end up in a situation when you're making some type of a morally qualifiable decision. It doesn't matter what is in the white box. What matters is how do we make the white box take into consideration ethical values and obligations. Typically, the example that whenever somebody starts talking about machine ethics is, this is from the moral machines experiment. You have the driverless vehicle whose brakes have failed, and it can continue driving on the street and run over a bunch of people, or it can swerve from the street and endanger the lives of the passengers. The moral machines looked into different vignettes with who is in the street, who is in the car. The reality of the matter is that this is most likely not the type of moral decisions that you would be making, because first of all, it's illegal to, run over people, and we can all very much agree that this is a bad thing. But you can have an interpretation of the new AI regulation that is being churned out now, and I think in Germany this is also already a doctrine in a way. That you shouldn't make this in Germany. In the automotive industry, there is already the requirement that you should not base your decisions on what bad things the car do on properties of people such as age, gender, and this kind of stuff. And the AI regulation in general designates as critical all systems that are able to harm humans in some way. And if this critical system does in fact end up harming humans, then what is recommended is not updating the ethical algorithm. You should have killed 3 people, not 4 people, but dismantling this and evaluating it why it made a mistake. So there will be no ethical reasoning there for driverless cars in this sense. So I like this picture. It's like, would you sacrifice eyes, lobsters to save the life of a cat? Is pretty much where these trolley problem examples of ethical decision making end up. It gets more and more convoluted, more and more complex, but in reality, this is not the type of problem that we will end up solving. So again, my opinion, this is why I told you which department they belong to. It's that the type of artificial moral agents we are probably looking at more and more of is something that of the type of content management. So the people are very, very nasty on the internet, and sometimes they send around stuff that is just unpleasant. Sometimes they send around stuff that is, or publish rather is the term. They publish stuff that is hurtful to other people. It can harm societies, as we saw during the pandemics. This calls to, resist wearing masks, or vaccines are poison and they don't actually work, and all that stuff. And you can even have complete smut, like revenge, what is the term? Revenge pornography and naked children and all that stuff. And somebody needs to make sure that this thing doesn't make its way through the internet. And typically this is a bunch of people, but there is much more posting than there is controlling, and there is a great interest to automatically moderate content. So this table that I'm showing here, that's the Twitter system for labeling information. When I took this photo, they were discerning between misleading information, disputed claim, unverified claim, and either doing nothing, deciding to do nothing, issue a warning, label it, or remove the content itself, which could be considered censored. It is actually censored. Now, the problem here comes when it's considered that statements can be misleading and unverified and disputed. If I say I ate an elephant this morning, nobody has an interest in removing that from the internet, because we kind of know that this is not a statement of fact, but it's like an expression of me eating a lot. But if I say something like my cousin died after getting their COVID shot, because it was definitely the COVID shot, nothing else, this has different repercussions. So you have to do what is effectively a moral decision. You're deciding to do an action that itself is not moral, which if we consider censoring immoral, right? In order to maybe improve the well-being of people in society. So these are by definition very much moral actions, and they're not at the same time discerning between legal and illegal actions, which is what the killing of lobsters and cats actually ends up being. So just to shift this idea in your mind as to what is the artificial moral agent that we are actually thinking of here. We are not thinking murder and mayhem. We are thinking values such as freedom of speech, such as autonomy, such as justice, these kinds of things. So for anyone that has ever programmed anything in their life, when I say you give morally qualifiable information about situational options to an algorithm, the question is, but how, right? So because we live in a very colorful world, but machines speak black and white, full or empty. So you have to somehow take these very ephemeral descriptions of what is right and wrong and shove them into data structures. Before that, you even have a chance to do that, there is the question of, can we actually have access to this type of information in the first place? Can we identify it, even in a human form? What are the morally relevant things that a particular algorithm working for a particular context, making particular decisions to take into consideration? And some of us think that, this is not going to happen. So a lot of work in machine ethics starts with assuming we have decided already and agreed upon what is the morally relevant, what is the right thing to do. This is how we build the algorithm. And it is, great work. But when have people ever agreed on things such as this? And if you want to take into consideration the opinion of more than one person, which you should if you want to act morally, then you have to figure out how to resolve possible conflicts to prepare that information in the first place so that you can input it over there. Now, whether or not moral disagreements exist, moral philosophers have different opinions. So a very strong branch in moral philosophy says, well, there is no such thing as a moral disagreement. We actually disagree on the part of how we interpret things. So the example that is typically given here is this idea of whether abortions are moral or not. And the claim is that we don't disagree about the morality of abortions. We all agree that killing is morally wrong. What we don't agree about is when life starts. So this is why this is not a moral disagreement. It is a medical disagreement or a religious disagreement, if you like. This paper discusses moral disagreement and artificial intelligence. It is from last year's IES, and it's a very thorough overview of the state of moral disagreements in moral philosophy. How how should we design, then it recognizes that the methodological problem that we face now is how should we design artificial intelligence systems that align with morality or our values when neither the designers nor those affected by these systems can agree about what's moral or valuable. So, you know, if moral philosophers get at you that there is really no moral disagreement, what conflicts are really solving that. So where can moral conflicts arise to? So to program a machine to do the right thing, we need to know what the right thing is. I was very surprised to find that there is a written up talk by McDermott from a long time ago, in which he says, well, you know, morality is all nice, but when it comes down to actually doing things, we use rules of thumb. So for one thing, the task of actually applying a correct moral theory to each of the ethical decisions we face every day would be difficult and time-consuming, and it seems unlikely for most of us that such a theory could have any more bearing upon our day-to-day ethical reasoning than physics has upon our everyday reasoning about objects in the world. So he says, yes, we all agree quantum theory is, you know, more or less right, but we do not apply it when we decide not to knock over the cup from the thing. Most of our common sense ethical thinking seems to be guided instead not by the dictates of moral theory, but by simple rules of thumb. Return what you borrow, don't cause harm, and it is not hard to generate complex among this. So, okay, I didn't put it on the slide, but I have it in the notes. This is the Moral First Aid Manual by Daniel C. Dennett, the Tanner Lectures on Human Values, delivered at the University of Michigan, November 7 and 8, 1986. And this is a paper that from which I actually got it on the slide. So how do we get then above this conflict? So there are different approaches here, and they're all fine ideas, but that's what they are, ideas. This guy, Adler, he says, well, okay, there might be different moral preferences, which is preferences over which rules should apply and we should take into consideration. We should find just a simple way to aggregate this, and then he goes into saying that there is an impossibility result for aggregation functions that satisfy this, which is what social choice theories do. My PhD is in social choice, computational social choice, so I'm kind of very well familiar with this environment. And then there is the real question of that I also want to draw attention to, because it also comes into discussions quite often, is that, okay, even if you by some kind of a way designate an ideal advisor who informs about what the rules of thumb should be, or moral values used should be that we use for alignment, it's not necessarily the case that they will apply for a very long time. So there is this thing that is called ethical relativism, which says that moral values differ from society to society, which is accepted or disputed by different moral philosophers. And then there's a real thing that is called tech colonialism, which says that whenever you build something, you build it building in the values that you already have in it. So the example I typically give my students here is you are given a description of a problem, which you say, well, the house, there is a row of houses. The first house is green, the second house is red, and so on. It pushes you to choose whether you order these houses from left to right or from right to left. And what you choose depends very much on which society you belong to, and then that is embedded in the program that you built. I love this comic book very much because it kind of illustrates that we are working with the values of our own societies always, but the machines that we build, they cross borders very easily, and particularly when it comes to software artificial agents, not devices, right? Because devices you can stop, software nobody stopping that. So then it can happen that you have the best of intentions of using this device in one society, and you think you know what the values are, but then it gets sold to another society. Or it could be that, you know, time just changes. So many different things can happen. So there is one paper I found that actually recognizes this, that the problem of figuring out collectively what the right thing for a machine to do is not as trivial as it might appear. This is social choice ethics in artificial intelligence. And Baum says, well, implementations of social choice ethics must take three types of choices each of which create their own set of ethical dilemmas. So in order to find a collective decision of what information should be, of right and wrong, should be passed on to your artificial model agent, you have to solve three problems. Problem number one is deciding who has standing. Whose opinion do you have to take into consideration? Now, if you think that you know this answer to this question, you're wrong, because there is much more to consider here than, is it just the users? Is it the developers? Is it governments? Because technology tends to transcend human lives, and certain systems that are in use now have been in use since the 50s. So then the question becomes, should we be asking the 70 plus and 90 plus who don't know anything about AI, or should we be asking the children instead who are far more deft when it comes to certain things? So it's an interesting introspection here. Then is the question of measurement. What procedure is used to obtain values from each member of the selected group? So you have decided whose opinion you want. Now, how do you elicit that? And how are the values, the last step, how are the values of each group member aggregated? So, assumptions that I work with typically is we will not choose a moral theory for machines and make an algorithm for it, because people do not typically use a moral theory to inform their moral decisions. That definitely we may not know what the stakeholders are, but we want to give all of them a voice, regardless of how many they are and regardless of how many times they change their minds. And then what we are basically going to be eliciting is something like rules of the thumb. So just a motivating real world example of how these rules of thumb conflicts arise. You may or may not recall the 2016 fury over Facebook Nipple Girls censorship that Norway kind of started in a way. The fury was Norwegian. So that was a post from one of the Norwegian newspapers on Facebook that included this picture that ended up being censored following the rule of no naked children on Facebook. Now, do not share nude children on Facebook. This is a rule that we want. We all agree on that. And Facebook used the violation of this rule as a reason to censor this photo. But at the same time, we should not be censoring the sharing of historically relevant material, which this photo also is. So can we satisfy both by finding a compromise? And this is what should that compromise look like? How do we get to it? How do we make sure we dynamically include opinions from different people? So the first attempt at this was this paper that we tried to build. We're using argumentation to take into consideration arguments from different stakeholders as to which is the rule that should apply, that kind of fight each other automatically, and then whatever is standing is the most unopposed rule is the one that is going to be taken into consideration. The newest attempt is trying to make norms coherent in a different way. So this is how the principle of this idea is. So you have some kind of rule which says if naked child, then censor. But then you have some kind of an exception to the rule which says if naked child and public domain, then do not censor. I have 5 minutes. Yeah, that's what I need. So what we were wondering is, well, okay, can we somehow change the first rule so that this situation when we have the rule and the exception is a little bit different than the situation in which we have two rules and they directly contradict each other. So we could have if child then do censor or if child then do not censor. And this is something that we see playing out right now because it was first Google then Apple that wants to pilfer through your photos of the cloud, and whenever they find pictures of naked children zoom in on you that you are being some kind of pedophile. Some people think this is a good idea because we are stopping crime, and other people think, well, it is my child and I have the right to share the pictures in the pool with its grandmother because I want to, right? So you can't deny either. So what we were wondering is, like, can we do something about the first case? Can we make the first rule more specific to include the exception, and then both of them can exist together, and we haven't overridden anybody's opinion, but we have something that we can work with. And we built an entire paper on that, and we thought it's going to be super simple and then move on to learning norms from multiple stakeholders, but the joke's on us. So the first thing we needed to kind of figure out is what this concept of common ground of agreement is, and we kind of called it agreement, consensus, compromise, and ended up on common ground because that's the one which didn't have tons of contradicting papers defining it. So we have to decide what to try to resolve by an algorithm and what requires human decision. And our point was, well, okay, the second group, when we have this direct human conflict, you can't throw an algorithm to that. That requires human decision, but the first thing, maybe we can just resolve it. So, but then the interesting thing is, what properties should the algorithmic common ground have? Like what can we change and what we should not be changing? And then, of course, what properties should the algorithm that builds the common ground should have? Because you may have something that's very powerful and solves all kinds of complex situations, but if it is untractable, then yeah, that's cute. Was the point of it. So we wanted something that is time and space efficient and should not require extensive knowledge and engineering in recording these norms. Okay, so this is not necessary slide. I should have removed it. So as properties of algorithmic common ground, we actually went through defining certain postulates that should hold, and to us they seemed very weak and very intuitive. Again, I would say jargonous. So the first thing is that we wanted coherence, and we introduced this concept of coherence. So what is coherence? We all know what consistency is in logic, but what is this coherence idea? So if you look at this rule, if nude, then disable sharing. And I should say that this is, read of this as prologue. So not share, okay, when nude, do not read it as a causal relationship. That would be bad. And this thing, if nude and in public domain or has consent, then allow sharing of this image. If you look at these two things, as rules put together, they're not inconsistent logically. They can exist. The problem arises that there exists a certain, but they are incoherent. So why are they incoherent? They're incoherent because there exists a certain fact that I can add to these rules, which makes this entire bunch too much clicking, which makes this entire bunch logically inconsistent. So coherence is this idea that there is incoherent is my set of rules. If there is something I can add to it, a fact that I can add to it, which makes the entire set inconsistent. So that's the idea of coherence. So the first requirement basically is whatever the algorithm produces, it should be coherent in the end. That there is nothing I can add to this set of rules that come out of it that would make it inconsistent. The second is this requirement, if it's not broken, don't fix it. So if all proposed norms are coherent, their union is the common ground. So you look at these guys, if nude, then disable sharing. If stolen photo and reported, then warn the account. If uncertain, then forward to human. There's nothing I can add here that will make this bunch inconsistent because none of the conditions are shared effectively. So the third one is, now we're getting into the more moral ones. So the essence of, starting from this idea that the essence of morality is to treat the interests of others as of equal weight with one's own. We interpreted that as a requirement that all stakeholders' rules are considered equally informative and should not be entirely overridden. So then we wrote this formal requirements that it shouldn't be the case that somebody's rules should completely disappear from your counted set of rules. So, and it shouldn't be the case that, let me just and it shouldn't be the case that you completely override some of these rules. They say if nude, then share, then there shouldn't be something that says that if nude, then don't share in the set. I have an example. Surprise for me too. So if nude, then disable sharing. If nude, then sharing is okay. So this shouldn't happen. If this was the rule that somebody contributed and nobody contributed this one, you shouldn't just kind of delete this and add this to the set of norms in the algorithm. But if it should also not be okay that you completely delete a rule altogether. This was another example of fill and paste. It should also not be the case that you completely get rid of somebody's opinion just because it's inconvenient to have it there whatsoever. So that was not okay. So then this is something that is not intuitive to humans, but again, if you ever programmed anything, you know it happens. All the rules of the common ground must be possible to trace back to the stakeholder that proposed them. It shouldn't be the case that something just appears there and you don't know who is the one who brought it in the first place. And the other requirement is, so this is the other requirement is that when I'm trying to expand a rule by using a weakening of it, logically, by using some exception, then the exception that I use in order to gain coherency should make sense. So I shouldn't use something just because it's there. So this is the example: if nude, then disable sharing, and if nude, then allow sharing. I shouldn't just add something. If nude, then consent, then disable sharing, and if nude, then no consent, then allow sharing. So this is something that is. Let me see what I'm doing here. Now, if nude, then. So yeah, okay. You shouldn't try to do something that it doesn't work, and you should. This is the example I was looking for. You should not use weakenings from a rule that does not connect to the rule that you're trying to weaken. So if I have this situation, if I have a rule in which I say something, if you don't have the consent, then delete the cookies. I should not use this consent in order to fix the rule that already exists there, because it speaks to a completely different norm that has nothing to do with this. It will fix my problem, mechanically speaking, but it is fixing it by inventing new things that shouldn't be there. So the algorithm basically, sorry, let me just run through it. The algorithm basically kind of works with Horn norms. So, and we are using propositional Horn to keep, and the choice to use Horn was because we assumed that most of the things we would like to express, we can express with propositional Horn, assumption to be verified. But our main motivations were twofold. The first motivation is we wanted an algorithm that is computationally efficient, not something that is NP hard or worse. And the second long-term motivation is we eventually want to use that to do some exact learning, other stuff, which only works if you have Horn, either propositional or first order. So how does the algorithm work? It cycles through the set of norms it gets on input. It finds two norms that have conflicting action, then check if the conditions of the two norms can be satisfied at the same time. Change the conditions, such as the stronger one is extended with an exception, and keep doing this until coherence is reached. And the only reason why we have a polynomial time algorithm is because we're considering two norms at a time. So we're checking them 2 by 2. If we were doing more than that, we would not have had. This is the algorithm which I'm going to flash, and you will not get a chance to read, but to know what to look for image-wise in the paper. And so what can we not handle with this stupid algorithm? We call a conflict when both the conditions and the action parts of the norm are negations of each other. So this completely conflicting rules, such as if nudes then censor, if nudes then do not censor, we can't handle that. So if this appears on input, you're going to throw it back and say, well, talk to each other. We can't do this. But more surprisingly, we cannot handle redundant rules. So if you have if nudes then censor, if nudes and no consent then censor. So one of these is more specific than the other. And because we are considering two norms at the time, this causes a problem. So we can handle this case, but we then lose polynomial properties. And we can't handle cycles because that does weird things with 2 by 2 rules as well. So if I didn't find a nice intuitive example for this, so just simple propositional logic. If P implies Q and Q implies R and R implies P, this throws our algorithm inefficient and impossible to handle either. So how efficient is it? It's not that bad. So it's a fourth polynomial. We would have liked, quadratic or something like that, but we were surprised that this is not the case. How expressive is it? Like, what are the things that you cannot capture in propositional form, or even if you go in first order form, what are the things you can't capture? We have to check that, and we don't really have a good idea how to check that, except of looking what part of English perhaps maps to what part of logic. I think KR did some work like this. And then it's the question of what is the knowledge engineering cost. So we cannot possibly tell people on the street, can you please give me a propositional Horn rule of what you think this algorithm should take into consideration? That's not going to work. So the question is, can we kind of get from some kind of a simple English or simple natural language into propositional form in an effective way? Again, to be determined. So our algorithms and postulates are just an idea. How can we tell that it is a good idea? So this work was done with Anna Ozaki, who is an expert on symbolic learning and neurosymbolic methods, and she's the exact learning person. And she has a bunch of master students trying to now implement it. Well, they have implemented the algorithm, they haven't found good examples to test it on. So if you have any kind of a bunch of norms lying around that you have gathered and you can share with us, we'll be happy to test whether our algorithm works, because this power of 4, we don't really know what it is in society. I'm interested in this problem in a fundamental way, so I don't really I'm not really attached to whether or not this is solved by resolving norms. Or it's solved by argumentation, or it's solved by anything else. What I find appealing to this, why I would defend to the death this approach, is because people often think that ethics is something that is socially determined, and if the right people in society decide that this is the right thing for machines to do, then we should just accept it. But machines permeate our life in much more private ways, and they are moral arbiters to us. We give up some of our autonomy to artificial agents. So certain things that were private before, that were within this space of I can act without unwanted scrutiny, now all of a sudden there is somebody in that space necessarily, because, for example, we always carry our mobile phone with us. We're always in the presence of some type of a device. So for me, this is a motivation to recognize that we should be allowed to make certain choices rather than having those choices being made for us. And if that is common sense, or if it is just simple preference, I just simply prefer things are that way, or if they are some kind of a moral value or moral qualification of a state or an action, that doesn't matter so much. But the issue that you have to constantly take input from users on this matter is the one that does matter, and that we should have some way of efficiently solving it. That's the main motivation. Okay, so this was mainly motivational, not instructional again, but thank you. Thanks.
Thank you very much. And thank our speaker.